Hi, and welcome back to another video. We got 6.3 today, which is about exponential growth, exponential decay, and compound interest. Uh, Two of these equations, these formulas should look very similar. They're both in blue. And then you've got a different one in orange. That's the compound interest. The growth and decay are the ones both in blue. And if you take a closer look at them, what you'll notice is the only difference is there's a plus versus a minus inside. The one for plus is exponential growth. The one for minus is exponential decay because everything's going down. And then the orange one is compound interest. All of these things are actually useful in life. Compound interest is the way banks deal with how much money you have to pay them extra when you borrow money from them, when you have a loan or something like that. And exponential growth and decay, there's a lot of things that follow this model. One of those things being viruses. So they have actually looked at like the coronavirus and stuff like that and other viruses, and the way it spreads is exponentially, which is why it's so important that everyone stays inside, is to kind of slow that exponential growth. And they have models for it that somewhat meet what we're looking at right here. This is obviously a simplified version of it from what they're using, but it follows the same basic principle. So let's take a look at exponential growth and decay first, and then we'll get into compound interest. For exponential growth and decay, there's a couple letters that you have here. A is going to be the initial amount. And for the initial amount, it could be the initial amount of money, it could be the initial amount of people, it could be the initial amount of a bacteria, anything. So whatever you're starting off with, this is where you're looking at. X in your exponent is going to be the time. This is however long you're dealing with it. Maybe you're looking at how something grows over 3 years, so that would be a 3. The R is your rate that it's growing as. And this is going to be a decimal. So like 30% growth rate would be 0.3. A 3% growth rate would be 0.03. Now, the one thing you have to make sure with this is that the rate and the time always match up. So if they talk about it grows 20% every year, then your time up here is automatically in years. If they say it grows that fast every day, so it grows, say, 30% every day, then your time would be in days. Where you can get tricked up sometimes is they'll talk about this as it grows 30% a year, and then they'll give you the time as 6 months. And if you go and put a 6 in, you end up getting it wrong. You would have to put in a half up here because it's only half a year. One of the things to watch out for, it happens sometimes, just don't fall for it. Now with exponential decay, it's going to look the same way. You've got initial amount is A. This is your decay rate. So how something's going down. And again, this is your time. Now when you're looking at graphs, exponential growth will look basically like what we were looking at before. It starts off kind of slower in the first part of it, and then as it goes up real fast. Exponential decay, when you're looking at the graph, will look more like that. It's going to drop off really quick, and then it's going to drop off slower. We've used the example in class where we always go half the distance, where I'd walk half the distance to the table, and I would get really close to the table but never actually get there. This kind of follows along with the same pattern. So let's take an example and see where we're at. Let's say I start you off with an initial amount of, we'll call it 100. The growth rate, and we got one of my cats trying to play with this here. Growth rate would be 10%. And we're talking about time being 3 years. So if we want to plug all this in, as long as you know where it goes into the formula, it becomes really easy to do. So you got f of x is going to equal to, a is going to be my initial amount, which is 100, Then inside I've got 1 plus. Now my rate needs to be as a decimal, not as a percent. So you need to put it back and it becomes 0.10. And then my time is going to be 3 for the years. When you start to simplify it, you get 100 times 1.1 to the third. Now again, we have to do exponents before multiplication. That means we need to do the 1.1 cubed and then multiply it by 100, and that's going to get us our answer. Now when you go and type it all into the calculator, you should end up with 133.1 as your final answer. Now if you're working with one of the scientific calculators, because these exponents are going to get bigger and bigger, there's a button on there that is basically like this, y to the x, or sometimes it's x to the y. Should be a y, not a 4. And these are going to be your exponent buttons. You would go like 1.1, you hit the exponent button, you hit 3, and that would give you an answer, and then you go and multiply it by 100. Now let's go ahead and do the same thing for decay and pick some different numbers. So our initial in this case is going to be, say, 300. Our rate is going to be 4%, and the time is going to be 4. So these are all the numbers that we're going to work with. You got to be careful with the rate in this case because you can't just put a 4 in there. It has to be a 0.04. So this would end up giving you f of x equals 300. In parentheses, I've got 1 minus 0.04. Make sure you put the minus in there because it's going to be decay. And then we've got an exponent of 4. Simplifying further, we got 300 times 0.96 to the fourth. And when I do this, I come up with 254.80. Now, when you're working with growth and decay, this number should be smaller than whatever you initially had. If you ended up with more, you didn't do something right. Same way with growth, we ended up with a number 133 that's bigger than the initial amount. That goes and proves that things are growing. The main thing is make sure you're getting the plus and the minus sign correct, and make sure you're putting in your percentage correctly. Any 2-digit percent, like 10%, 12%, it's just going to be point and then that number. But with the numbers smaller than 2 digits, so 5%, 9%, you better have the 0.0 there. Otherwise, you just made that 40%, and that means it's going down a whole lot faster than what you've initially got. Now, let's talk a little bit about interest, and I don't think I spelled that correctly. Now, if you have no idea what interest is basically money that banks will pay you and charge you depending on what you're doing. If you put money into a bank account, into a savings account, you'll actually earn some extra money. They usually give you maybe 1.5% to 2% money. So if you put $100 in and for a year and they give you 2%, well, at the end of that year, you now have $102 in your bank account. Big bonus there. Now, when you buy something and you get a loan from the bank, they're not doing it out of the goodness of their heart. They charge you interest, and sometimes that interest can be 4% or 5%. Basically, they're charging you more than that they're giving you. So they're taking your money when you put it into a savings account and lending it to somebody down the road from you and charging them more money. So they're going to take their 4% back and they'll have to pay you, but then they keep a bunch for themselves. And that's what interest is. And there's different ways that you can do interest. You've got simple interest, which just figures it once over the whole course of the time period. And then you can do what's called compounding. This is when they go and take interest and do it multiple times. So they'll basically calculate your interest multiple times, and this works out. If you're gaining money from this works out to your benefit because they're going to compound your interest. You get a little bit more money from that, and then when they do it again next time, you, instead of just being your initial amount, you get whatever they added in for interest. So if you put $100 in, and when they calculate your interest the first part of the year, maybe you get an extra dollar. So now you're up to 101. So now when they calculate your interest next time, instead of using the initial 100, they go and use the 101, which means you're going to get a little bit more interest. Now there's a couple different ways it's normally done. If it says it's being done annually, it's once per year. So at the end of the year, they'll go and calculate interest with whatever money you have in your account. Another popular one is quarterly. This means they're going to do it 4 times a year. So basically, they'll every 3 months or so they're going to calculate your interest. The more times they're compounding it, the higher that interest rate, that higher the amount of interest is going to be. So if you're earning money, you want them to compound it more times because that's going to get you more interest that they're going to pay you. If you have a loan, you don't want them to compound it more because that means you're going to have to end up paying extra interest because they're calculating the interest off of the old interest. The other one that you might see, and this could be put a couple different ways, is biannually, which is 2 times a year. So this basically means at the midway point of the year, they're going to go and calculate interest, and it's basically done twice. So you have to know these. Annually is once, biannually is 2 times a year, quarterly is 4. Anything other than that, they'll say like they'll calculate it 8 times a year or 10 times a year. They essentially just use numbers for those. These are the words that you have to know. Had to get some more paper there. Most of you have seen the simple interest formula and you've calculated it. You plug in a few things. That's basically doing interest one time. So let's take a look at the one for compound interest. Now, the way this one works is your P is going to be your principal. And this is essentially what you're starting off with. So if you're putting $500 into a bank account, this would be your initial principal that you're going to be earning interest off of. If you borrow $500 from the bank, this is the initial principal that they're going to be earning interest off of. So principal goes both ways, whether you're borrowing the money or whether you're putting it into a savings account. They won't always use the word principal. Sometimes I'll say you invest $500 or you take a loan out for $500, something along those lines. Just figure out whether you're getting the money or whether you're giving them the money. The R is going to be your interest rate. And again, you need to be careful when you switch this with the decimal moving back and forth. The N is how many times they're going to compound it. So how many times a year are they calculating? Are they doing it quarterly? Then that number would be a 4. Are they doing it annually? Then that number is a 1. Up here, this is going to be the same N, and this is going to be the time of the loan. So how long you're borrowing the money for, or how long you're leaving the money in the account. And once again, it just comes down to, just like with the growth and decay, if you can remember this formula and keep track of what everything is, it's just a matter of going and plugging everything in and then using a calculator to solve it out. So let's take an example here. let's say you go and put in $10,000. So you're going to put $10,000 in the bank. You're going to put it in for 6 years, and you're going to get 2% interest, and they're going to compound it quarterly. So that's all the information that you need to actually go and plug this in. So this might be something you inherited some money, you won the lottery, whatever it is, you're putting some money tucked away in a bank account, and they're going to give you some interest because they're going to want to lend that money out to somebody else. So when you go and plug everything in, you get A equals 10,000 times 1 plus my interest rate is going to be a 0.02 over, since I'm doing it 4 times a year, it's 4. And then up here, I've got 4, and it's going to be a 6-year loan, so it should look like this. The 10,000 is the principal. The 1 is always there from the formula. My 2% turned into 0.02, and on the bottom, since it's going quarterly, it's a 4. And then up top for my exponent, I have 4 times 6. Now, if we start simplifying this a little bit, and you got to be careful typing all this into a calculator. It's really easy to go and get things wrong. So this gives me 0.02 divided by 4 is 0.005, so this becomes 0.1005, and 4 times 6 is 24. Now, once again, we have to watch out with order of operations. This, at this point, is basically the same thing as exponential growth and decay. You've got a number in here, you've got to raise it to the exponent of 24, and then multiply it by 10,000. This is where it becomes real important that you know how to use that exponent key, because going 1.005 times 1.005 times 1.005 and doing that another 21 times, the chance of you making a mistake is pretty high. So now would be a good time to plug all this into a calculator. Now, when I put everything into a calculator, I end up with an answer of 11,271.59 without rounding and just kind of chopping it off at 2 digits. So for your $10,000 that you stuck in the bank, you got a difference of $1,271.59. So at the end of the 10 years, they're not only giving you back your $10,000, they're giving you back almost another $1,300. And that's basically what they're willing to give you in order to use your money. Now, banks aren't nice. They're not doing this just to help you out. They want to take your money and lend that to somebody else. So let's go ahead and take a look at if you're doing this as a loan and how that might look a little different. So let's take the same $10,000. So let's say they take your $10,000 and loan it to someone to buy a car. Now, if that person is a first time buying a car or they don't have very good credit, all of a sudden that interest rate could be as high as, say, 15%. And let's say it's still going to be done quarterly. So this is your same $10,000 that you're putting in the bank. We go and plug everything in. We get A equals 10,000 times 1 plus, in this case, it's going to be a 0.15 on top and a 4 on the bottom, and then a 4 times 6 up here. Now we start going through and simplifying a little bit. 10,000 times I get 0.0375, so this would be 1.0375, and again up top I get 24. Keep these decimals here. You don't need to use it if it comes out to be like 30 or 40 of them, but 0.0375, you should use them all. It's going to make it more accurate. When you type the numbers in, it may not work if you don't do that otherwise. And what we have to do is go through and do all the math on this. So I'm going to pause it real quick. Now, after doing the math, what I come up with is 24,194.38. And again, there's no real rounding. I just chopped it off at 2 decimals. So essentially, there's a difference here of $14,194.38. So when you buy this car that costs $10,000, here's a quick little life lesson. You're not just paying back the $10,000. You're paying them, if you have bad credit, an extra $14,000. Obviously, the better the interest rate, the lower that number is going to be. But in this case, you're actually paying more in interest rates, more in interest fees than you are for the actual car. Now, here's the way the banks make their money. If you remember, the person who deposited their money, they paid them $1,271.59. They collected from you $14,194.38. So if you take 14,194.38 and subtract away 1,271.59, the bank came out making almost $13,000 profit. So basically, they take money from one person, hand it to another person, and then collect that money back from the other person, hand it back to the other one, and keep a big chunk for themselves. If you start trying to think of what could reduce your interest rate and what would change your interest and make it better, the biggest thing that's going to lower the amount of interest is obviously the rate. If you've got good credit, instead of that being 15%, that might be 4%. So you might be talking a $10,000 difference in savings there. Another thing that would change it is looking up here, what if this 24 was a smaller number? If I do this over 5 years, instead of raising it to the 24, I'm only raising it to the 20, which dropping 4 off the exponent makes a big deal. So if you end up paying your loans off earlier, that will save you some money too. That'll change the interest. But on the reverse, as these years get longer, because maybe you don't want to pay as much money up front, the interest is going to climb. So these are all things that kind of change it. If you have questions, feel free to email me. It helps if you email with work shown so I can see where you're going wrong. We'll have some Zoom meetings. There'll also be a test this week. It'll be the first one. I don't really want it to cover too many topics, so it'll cover just 6.1, 6.2, 6.3, and I'll have a review for that coming out this week. Hope this helps.